Hello students, today we will study about the universal indicator, that is pH. Why is a pH scale known as a universal indicator? You must have studied about the litmus paper, methyl orange, phenolphthalein and olfactory indicators. What do these indicators have in common? These indicators only tell us about the acidic or basic character of a solution, but they do not tell us the strength of the acid or base. Whereas if we talk about the pH scale, it indicates the character of a solution. That means it tells us whether the solution is acidic or basic, and it also tells us about the strength of that particular acid or base. And so it is known as the universal indicator. The universal indicator is available in the form of solution or paper strips. It uses different colors over the range of pH values from 1 to 14 for a given solution. This is how the color on the pH chart looks. pH value from 0 to 6 shows acidic nature, and the pH values from 8 to 14 show basic behaviors. What about the pH value of 7 then? The pH value of 7 shows that the solution is purely neutral. Let us dive a bit deeper into this concept with some basic information about the pH scale. How can we judge how strong an acid or a base is? This is exactly what the pH helps us with. But how does it do that? See children, the pH considers the concentration of H positive ions. Now you must be wondering, how can it tell us the strength of a base if it only considers H positive ions? Remember, bases also have H positive ions, but their concentration is far lower than that of the concentration of OH negative ions. So low that they are generally ignored. The value of pH is inversely proportional to the H positive ions. This means more the concentration of H positive ions, lesser will be the pH value. Now if you look at the pH scale, as we go to the left, the pH value is decreasing, which means concentration of H positive ions increases. And as we go towards the right, pH value is increasing, which means the concentration of H positive ions reduces. As we know that the higher concentration of H positive ions implies that the solution is more acidic, so we conclude that the acidic nature increases as we go towards the left. And as the basic solution have lower concentration of H positive ions, the basic nature increases as we go towards the right. Let us see what color most of the common substances result in and what are their strengths according to that color. The most common acid that we know is HCl, hydrochloric acid. It has a pH of 1.2. That means it is a very strong acid. And as you can see in the picture, its color is red. Lemon juice has a pH of around 2.2 to 2.4. It is weaker acid than HCl and its color is orange. What about coffee? It has a pH of 5. That means it is a weak acid and its color is yellowish green. Distilled water has a pH of 7. That means it is completely neutral and its color is dark green. As we move further, the human blood has a pH of about 8. That means it is a very weak base. Its color is light blue. Baking soda has a pH of 9, which tells us that it is a weak base, but it is stronger than the human blood. Its color is dark blue. Sodium hydroxide has a pH very close to 14, which means it is extremely basic in nature and its color is violet. I hope the concept of pH is clear to you. In the next video lesson, we will see the importance of pH in our everyday life.